Okay, let's just jump right in. Think about this. Every single time you browse a website, shoot off an email, or binge watch a show, you're tapping into something crucial but kind of invisible. That's the application layer. It's like the penthouse suite of the TCP IP model, where all the magic you see on your screen actually talks to the network down below. So in this explainer, we're going to pull back the curtain and see exactly what it does and, really, why your entire digital life depends on it.
So, you ever just stop and wonder how your apps actually talk to the internet? I mean, how does your browser, or whatever messaging app you're using, communicate across this massive, tangled web? How does it know what to ask for, and how does it make sense of what it gets back? Well, that is the exact question we're tackling today, and guess what? The answer is the application layer.
To really get it, let's think of this layer as the internet's ultimate translator. It's the middleman, sitting right between your software and the raw network, just making sure everyone's speaking the same language.
Now, here's a really important thing to get straight. The application layer is not the app itself. It's not Chrome, it's not your email client. Nope. It's more like a toolbox full of protocols. And these protocols are just specific sets of rules that your apps use to ask for, send, and get information in a way that actually makes sense.
So yeah, this layer is the direct link for your apps. I mean, everything you see and click on. A website, that send button, a video player, it all relies on the application layer to translate what you're doing into commands the network can understand. And then it translates the network's answers back into the stuff you see on your screen. It really is the essential bridge connecting your world to the super complex network humming away underneath.
So let's crack open that toolbox and check out the greatest hits. You're going to see that these are the protocols that power pretty much everything you do online, and they're just chugging away behind the scenes 24/7.
First up, the big one. HTTP, the Hypertext Transfer Protocol. This is the absolute foundation of the web. It's the language browsers and servers use to chat and exchange web pages. And then you've got its cooler, more secure sibling, HTTPS. The S is for secure, and it just adds a super important layer of encryption. Basically, it scrambles the data so nobody can snoop on it. That little lock icon you see in your browser? Yep, that's HTTPS doing its thing.
All right, next up, DNS, the Domain Name System. Seriously, think about this for a second. You don't type a long string of numbers into your browser, right? You type something easy, like google.com. Well, DNS is the internet's giant global address book. Its whole job is to translate that human-friendly name into the numerical IP address that the network actually needs to find the right server. Without DNS, the web would be impossible to navigate.
And we can't forget email. This whole system runs on a power couple of protocols. First, you have SMTP, the Simple Mail Transfer Protocol. That's the engine that actually sends your emails out into the world. And then there's IMAP, the Internet Message Access Protocol. That's the magic that lets you check and sync your inbox on your phone, your laptop, your tablet, everywhere all at once.
But look, the application layer does way more than just manage conversations between computers. It's also in charge of the data itself, like how it's formatted so it actually means something, and maybe most importantly, how it's all kept safe.
So think of it like this. On one side, for us humans, or at least for our apps, you've got these nicely structured data formats like HTML or JSON. They're easy for an app to read and understand. But for the network itself, it's all about raw binary data, just ones and zeros. The application layer's job is to take that meaningful, structured data and package it up into those raw packets that can actually fly across the wires.
And here's the kicker. Because this is the layer that handles all of our most valuable info, we're talking usernames, private messages, credit card numbers, it is, you guessed it, the #1 target for cyber attacks. It's where the data lives. So security at this layer isn't just a nice-to-have, it's an absolute, non-negotiable must.
So to fight back, the application layer has its own security toolkit. You've got TLS, Transport Layer Security. That's the encryption that makes HTTPS secure. It also handles authentication, using things like API tokens to make sure you are who you say you are. And then you have Web Application Firewalls, or WAFs, which are basically digital bouncers, checking all the incoming traffic and kicking out anything that looks shady before it even gets to your app.
All right, let's start to bring this all home. Let's just zoom out for a second and really appreciate how fundamental this layer truly is. It doesn't just power our apps, it actually makes the whole idea of networking way simpler to wrap our heads around.
So if you're a bit of a network nerd, you've probably heard of the 7-layer OSI model. It's a bit complicated. Well, the TCP IP model, which is what the actual internet runs on, is way more practical. It basically takes the top 3 layers of the OSI model and squishes them all together into this one single powerful application layer. So much simpler.
And at the end of the day, it all comes down to this. Whether you're browsing a website, sending an email, or using a cloud app, it doesn't matter. You are directly using application layer protocols. Almost everything we do online, every single day, starts and ends right here.
So, if you remember just one thing from all this, make it this. The application layer is what makes the internet usable. It's the magic that transforms a chaotic mess of data packets into the rich, interactive world we know and depend on every single day.
And that brings us to one last thing to think about. All these protocols we've talked about, they were invented to solve the problems of their day. So what about tomorrow? If you could invent a brand new internet protocol right here at this layer, what problem would it solve? What would you have it do?